Okay, good. I hope you are impressed or amazed or whatever it is, mesmerized by the content-based filtering, the power that Pandas gives us in very compactly, descriptively, and clearly express precisely those, extraction that we want. Okay, so we now are able to not only extract based on the positioning, the column labels, index labels, but also by content and by complicated filtering of the contents, not just broadly, easily expressible contents, but also very fine grained, very well defined, complicated uh, way of filtering out those contents that we don't want or extracting those contents that we want. So let's hop over to the Spider Lab and begin our exploration. So here we have a clean slate, and let's begin by creating our data frame 6. Okay, so again, we need to import these two libraries, okay, NumPy and Pandas. So now we have df6, and earlier on we were trying to perform content-based filtering using using B, the column B, right? So just copying and pasting from the slide. Right. So extract column B and convert it to a mask, and this mask is to be supplied to the selector based on the base content of df6. Right? We don't actually have to base it on df6. It could have been another data frame of the same shape, as you probably have guessed, and that's true. You can do that. Okay, so true enough, dfb will in the result have values that are 7 or larger. And what about df6? No change, right? Because the selection is always returning a new copy, always by default based on the data integrity principle. Okay, so that is to return the data frame itself. What if we're not interested in the data frame? We're just interested in which row labels contain that. Now, that might seem visually a very simple thing. There, the leftmost. But that means you must print it out, eyeball it, and then uh, program it back. Imagine you're not dealing with my df6, you're dealing with my df6 billion, all right? What are you going to do? You're not going to eyeball 6 billion rows. So you really need a programmatic way to do it. And the way, as we have learned, is extract df6's index, then apply the selector mask to it. Or else, calculate as per earlier and then extract out the dot index, right? Both ways work. Let's just look at this way. And we get this strange looking type, right? But that's just pandas series that is reserved for use as an index. If we're not sure, we can always force convert the result into a list and we'll get back 1,6. After that is familiar territory. We know what to do. Okay. So we can also, of course, do the obvious. First, calculate the whole data frame result and throw away the data frame, but just extract the row index. And this would work also. Sorry, that's the wrong key. This would work also, right? So we have 1 and 2, and you can always force list convert it into Python's list. Now, next, we want to talk about how to have more complex filtering based on several criteria, right? Based on several criteria. So we want, other than the forced list converting, we want to base it on df6, the index, all right? And first we want the column B to be ranging from 3 to 5. So for this part, we can put it in the same line. and right, and the whose column A has to be equal to 2. Yeah, okay. So and then we apply that mask onto df6.index. So that's going to give us some sort of an int64 index thing, right? And then we force convert it using the list. So hopefully by now you're not, instead of being intimidated by, wow, what is this, right? You're able to sort of look past the list, because that's the last thing we apply to force it, right? That it's not doing much. And we get the idea that everything is to be done onto df6's dot index, which is this range here. That means which row label has all these properties. And what are the properties? The properties are, look at the column B, it has to be in the range 3 to 5 inclusive. And that means you look across to column A, whose value is 2, exactly 2. Okay, so let's print it out. Which rows have that? Oh, rows 3 and 4, right? So if you recall in our slide, where is it? Our rows 3 and 4, exactly. So we have this. Okay. Now, of course, if we don't do IND3, but instead we do DF6 3. Okay, so we don't have a list. We're not going to base it on the index, but base it on DF6 itself. Then what do we get? We will see, that's not something that we have seen in the classroom slides, right? But we'll see now. And that's why the lab, that's what the lab is for. So now we will see, well, it's a bit slanted because ABCD will describe ABCD, the 4 columns, and we have row labels 3 and 4 containing the entire row's contents because it is based on DF6's contents. Okay, so far so good. Now, next, let's look at how we can identify or answer questions like how many cells satisfy uh, certain criteria. So our discussion just now was like this, right? Look at the entire data frame, give me a mask greater equal to 6. And then we can print them out. Right, so those are exactly all the temporary variables that we have set, that we have discussed, and we print them out. So our df6.l is going to be a mask consisting of true false values and with exactly the same dimension and column labels and index labels as our final base df, which is df6 itself. Then we have a temporary variables of column sum. Now column sum we know is customarily written at the bottom, but Panda series being a series, if you print out horizontally, it's very limited to print and it looks very ugly. So even though we think of it as column sum, so it's a row, right? By pandas, when you print it out a series, it's going to look vertical and the ABCD becomes vertical. So this, to beginning learners, sometimes is quite a bit of confusion. It's like, I didn't change my columns to be rows. Why is pandas telling me they have suddenly become rows, right? That's not true. Huh? So columns are still columns in df6 and df6 underscore l, but this is a series, a separate copy. Yep. And what about tt6l? Right, that is just a number. Okay, what is the type of tt6 underscore l? Sorry, tt6 underscore l. It's a numpy integer, which is numpy's own version of integer. All right, so it is interchangeable for use anywhere with integer. So that's totally fine. And let's try the condensed form, which is to say how many cells are greater or equal to 6. So we say it would be this number, df6 greater or equal to 6. That will give us the mask. Then we do a column sum, which will give us 0, 2, 2, 2, right? And then we perform a sum of that series of 0, 2, 2, 2. should give us a 6. Okay, so it looks quite amazing. What is this one-liner doing there? But once you have gone through this slow motion, hopefully you didn't fast forward the video and skip parts of it, then you have really a good in-depth understanding of this example. And this example is very typical, right? I mean, all your other future programs will be different from this, but it's going to take up similar logic, similar thought process, similar chain of dots to get to what you want. Okay. And we also talked about in our classroom here, we also talked about using pre-written function that can be simple, but usually can be much more complicated because it's a well supported mechanism to write complicated logic in a function. So we can definitely do that and apply map. Okay, so let's answer this question. Give all the rows having at least 2 odd numbers larger than 4. So answer is going to be rows 1 and 6. All right, let's begin by writing my filter. So my filter will be to check if the cell value is greater than 4 and is odd, and then return true, otherwise false. Yeah. Then what we can do is we will apply map my filter, and there's no need axis because it's all the cells. So apply map. So we get this mask, right? So mask is basically the same as data frame or series, except and the entire content is either true or false. Then we use df6 odd to sum row-wise across, right, to get row sums. And that will give us a series, not as part of the df6 odd data frame, right? So it's a separate series like this. So just check that it is true and true, so that's why it's 2 here. And this is 1 true here, so that's why it's 1. Okay, we are almost there. And all we need to do is to convert this series, this SS6 odd, into a mask. Whenever it is 2 or more, like this, right, set it to true, otherwise false. Okay, so what we do is we now can see that it is like a mask now. So it's very simple now. We just insert it into the base data frame or else the base series, depending on what we want. So the base data frame is df6, select based on the mask, finish. Right. So df6 of want is 1 and 6. So that's basically the long way of doing things, but we can definitely say, I want this. What is this? This is given by df6 apply map of my filter, which will extract out the a data frame of true false, right? Then I will basically perform a sum of across the row, and whenever this resulting series is greater or equal to 2, I want. So the entire expression is going to be surrounded by a bracket just to be safe. So this expression will return to me the true false, which is basically SS6 underscore true false. That's almost there, but not there. So what I want is to put the entire thing inside the base df6. All right. Where are we? Okay, close it. And that's it. So with this, hopefully by now, you are really not intimidated by all these expressions because you are beginning to get a sense of where to look for, right? So I look at this inner side first, then get the true false and move from there on. Yeah. Okay. So that ends our experimental session to discuss about content-based filtering. So join me in the next video and we'll examine more aspects of pandas.